Hello everyone, I am Sonali Mate and I welcome you all for the session on Dynamics of Machineries. So let's talk about unit number 5, Vibration Measurement. In that, today we are going to discuss on a topic that is condition monitoring. So the learning outcome of this video is that the student will be able to understand the working condition of any machine before failure. So what is condition monitoring? So let's understand it. So, in our daily life, we have heard about a sentence that is, prevention is better than cure. It means we always take some remedial action in order to cure a hazardous or a failure condition. So, let's take an example of coronavirus. Nowadays, we are facing the coronavirus effect and we are talking about the prevention in order to avoid it. So, what are the preventions? We use mask, we wash our hand regularly, we avoid handshake, we avoid social gathering, and also as a prevention we have to consult with a family doctor in order to have a good health checkup. So this will prevent us from the coronavirus. So similarly, there is another one example. There is a fire, and we all know that regularly we check the tire air pressure. Why we are checking it? We are checking it because if the tire pressure is lower than its lower limit, then it might sense some vibrations, it might face the puncture situation. So, what is condition monitoring? It is to determine the condition of machine with the change in time. So, we have to deal about the working condition of machine with respect to time. So, here is an example of fan motor, or you can take any component or any machine. You have to check its condition, working condition regularly in order to avoid such a dangerous situation. Like if the machine fails or if any one of the component fails, then it might be hazardous to the human being also. So condition monitoring is very important. Also, if a machine component fails, so ultimately it increases the cost, the repairing cost and all. So condition monitoring saves time, cost, and also it is safe for the human being. There are some signatures. Signatures are nothing but the changes in the parameters of the machine. Parameters such as vibration, noise, temperature, wear debris, oil contamination. So the analysis of these signatures will prevent the failure of a machine. So what we have to do is we have to check the condition of the machine based on this signatures. So let's talk about condition monitoring techniques. So first is visual and oral monitoring. So in this, a skilled technician or an experienced person is there who simply visually or by orally he monitors the machine condition. As he is an experienced person, so by sensing some vibration or noise, he can find out or diagnose the fault in the machine. So this is how the condition monitoring is done by visual and oral monitoring. Next is operational variables monitoring. In this, functional work is considered. Now, if suppose the machine is working on a certain pressure, so the condition is that the function of the machine should take place at that pressure. So deviation from that functional work will be hazardous for the system. If suppose there is more deviation, it means the machine is not working properly. Next is temperature monitoring. Now in this, we have to measure the surface temperature of a machine or any component. Now, when the temperature will increase, when there would be more friction and wear, and this friction and wear will be due to inadequate supply of lubricant oil. So, if we found there is this increase in surface temperature, it means there is inadequate supply of oil or there is some wear and tear of the parts. So now, for such type of monitorings, the devices are used like optical pyrometers, thermocouples, thermometers, etc. So the next technique is wear debris monitoring. In this, we are considering the wear particles. which are generated due to friction between the two moving surfaces of the machine parts. So these wear particles are found in the lubricating oil, which are used to identify the extent of damage. If the number of wear particles are more, it means there is more damage of the part, and if it is less, it means the damage is less. So this technique is suitable for the machine components like bearing, gears, pulleys, etc. Next is vibration monitoring. This technique is widely used for condition monitoring based on a vibration. Now, this vibration signature of machine is related to the health of machine, and it shows the unbalance, misalignment, lack of oil, wear, noise, etc. So, since by sensing this vibration, we can find out the actual fault in the machine. So here we can see a graph which is acceleration versus frequency, in which we are having a two graph. One is for when the bearing is new and when the bearing is old. So here you can see when the bearing is new, it is having comparatively less peaks than the when the bearing is old. So high peaks represents the amount of vibration is more at this particular frequencies. So by comparing this graph, you can find out the condition of machine. Now there are basically two vibration monitoring techniques. First is time domain and second one is frequency domain. The time domain analysis, we are having a graph that is acceleration versus time. So here it is time domain spectrum for a gearbox. So this graph is shown for gearbox, which is acceleration versus time. Now this is for the new gearbox, and another graph is for old gearbox. Same one, there is one gearbox. Initially, when it is new, we are getting this graph, and when it becomes old, we are getting this graph. So what we can see, as it becomes older and older, due to friction, due to wear, due to some misalignment, due to unbalance, or due to some looseness, there is a chance of vibration, and this is sensed by this graph, or this we can identify from this graph. So here you can see that more peak points are there in this graph as compared to this. Here you can see that equal amplitude is there with respect to time, and here it is varying amplitude, and this shows that the condition of the gearbox is not. Next is frequency domain. It helps to understand the condition of machine in better manner with the help of a frequency measuring instrument like FFT analyzer. So this frequency domain gives us quick response to change in excitation force. As your excitation force changes, the amplitude will also change. So it gives a quick response as compared to the time domain graph. And each element in the machine has identifiable frequency. It means the change in graph or a spectrum at any particular frequency will be helpful to understand directly which machine component has been failed. So let's understand it with the help of a graph. Here is a gearbox to which input is given by motor and output is pump. So number of bearings, shafts are used over here. So here is the frequency spectrum for this machine. Now here you can see the graph is amplitude versus frequency. So the first one is for a good condition machine, and the second one is for the bad condition of machine. So here you can see when you are comparing these two, you can find that at bearing number 1, we are having higher peak in case of bad condition. Similarly, at bearing 4, we are having higher peak. Even at bearing 6, we are having a higher peak. Gearbox, we are having higher peak. So comparatively, here you can see in this graph, we are having higher amplitude. So this represents that the machine is having high vibrations, and this shows that the condition of the machine is not that much good. So in this case, simply by using all these condition monitoring techniques, we can understand the defective condition of a machine part or a component initially, and we can work on it in order to avoid the failure of a machine. So condition monitoring is very important. This monitoring is supposed to be done after specific interval of time in order to understand the working conditions of machine. So I hope you have understood. Thank you. If you are having any queries, you can email me. And if you have liked my video, kindly like, share and subscribe it.